Welcome to this webinar by John Hager. Um, and we would be calling him up soon on the stage to share his knowledge with us. Now, before starting, a huge shout out to our sponsors, Browser Stack. A huge shout out to them for being our exclusive sponsors for all small events and premier sponsors for all conferences. It is because of them we are able to do all these events for you all, and we are able to share all this knowledge with all of you. So, thanks to them. Now, without wasting any more time, we have John with us right now. So, John is a senior tester with over 40 years of experience in software development and testing. John has worked in business analytics, systems, and software engineering, specializing in testing, verification, and validation. Uh, Currently, John works as a consultant for Grand Software Testing LLC, and I would love to call John on the stage so that he can, better describe what he does, how his experience of 40 years has been, and share a little bit about the topic of today. Hi, John.
Hello. I'd like to thank you for uh, listening to me for the next 50 minutes or so. And we've got some charts. And I want to talk about kind of an exciting future for testing, Internet of Things, and AI. And they're very closely related. So I'm going to go back and forth between those two, particularly with a focus on verification, validation uh, with automation, uh, security, which very worrisome to many of us, in data analytics. And that's me down there in the bottom. And yes, I'm actually a cowboy. I live on a ranch in the mountains of Colorado. But I mostly work nowadays with ISO and some people in ISO from India and IEEE. And just so I have some credentials, I've got the two books there that are one's a year ago and one's a little bit older, but still apropos. I'll refer to those off and on. I'm going to turn my video off uh, just so we don't crash my system here. So next chart. Okay, a little bit of introduction. Internet of Things and AI are both big hot growth areas in tech, but they've got some issues and problems that we have to think about. Chief amongst them that I've seen is, when do we stop testing and what do we test? Do we test just the AI engine? Do we test the support things around the AI? On the Internet of Things, a lot of managers just want to test the device. But Internet of Things plug into the internet, hence the name, and you've got connections going out. To me, it seems like those have to work also. So we'll talk about testing that. AI, I'm going to give you my opinions of how to test AI. I will put in a disclaimer there. I'm on several committees that are dealing with testing of AI. There is not universal agreement. I've got very good friends that look at it one way. I look at it a second way. And then some of the people in the committees look at it a third way. So testing of IoT, AI, it's going to change. So anything I tell you here, if it changes in the next year or two, do not be surprised. But it makes it a fun situation. So I want to talk in the presentation a little bit about the situation, what verification and validation is above just testing, a little bit on automation and modeling, and some tools that support that. Standards, you either love them or hate them, but they have a place. And then skills, both for testing these things, security, and AI and data analytics. I've written some articles that people are like, well, the testing jobs are going away. No, they're going to change. And manual testing, yeah, that may be taken over by automation and AI. But thinking testing, and in the US, we just had the government come out listed 3 areas that were very important for AI and IoT. One of those was testing. Next chart. So, IoT and AI, they're going to be everywhere. They're going to be everything. We're plugging things in rapidly. You see some numbers there, millions, soon billions. There's the consumer side, which has a list of things. You have the industrial side, so-called IIoT, and a lot of things going on there. And then there's kind of the middleware, medical devices, tracking, transport, safety, robotics. All those things can be Internet of Things. All those things can be connected to the internet and connected to AI systems. Hence why I look at them as kind of all closely related to each other. And that picture at the bottom there, that's called a snowcat. I realize India doesn't have a lot of snow. Been there several times. Very nice place, great food. But where I live, we have snow 6 months out of the year. I'm going to talk about the fun things with my snowcat here as we go through this. Next chart. So I mentioned the terms verification and validation. Here's some definitions on those. And verification, primarily concerned with testing to make sure that we meet the requirements and design specifications. Validation is more at a system level and kind of asks, did we build the right system? You can build the system perfectly from a verification standpoint, but still not have it meet the needs. Validation, a lot of people want to stay away from, but when we get to things like AI, I believe validation is going to be important because people are going to want it to do something and not do other things. So verification, validation include testing, but some other things that we'll look at here in a bit. And we can't just test these systems now, IoT and AI, in isolation. We used to do that in many of the simpler systems going back. I've been in the industry for over 40 years. It was no big deal. Everything was easily tested and standalone. Now everything's integrated. Everything's on the internet. And one of the areas that V&V is going to go into is well-practiced places in the U.S. is independent verification and validation. And again, the government, the U.S. actually just called that out as one of the areas that they want to see independence in the V&V testing. Why? Because sometimes the projects, the people doing things can get kind of one-sided and ignore the big pictures of society. And this stuff is going to drive a lot of technology in the capitalist world we all work in. Everything's coming in, going to be connected. But you'll see here as we go through this, I think you have to consider not just the testing and the V&V, but the environment, the architecture. So I'm going to talk about that a little bit as we go through. Next chart. So what do I mean when I talk about these connections? Well, rather simple picture. And there's obviously many variations of the picture, but you have a home system, kind of like the home I'm in, where you have a variety of smart devices and smart systems connected maybe to a router in the house, and then connected to some outside connection, edge. In the case of my systems, we do everything through cellular technology because of where we live. And from there, you connect out to the cloud and store the data and the AI in the cloud. And there's a constant back and forth between all these things. And as I said earlier, a lot of projects are just going to want to test, maybe that one little camera in the home, ring device on your door. But that doesn't answer the bigger question of, does it communicate with the edge? Does it communicate out to the cloud? Does it, really provide safety and security? So this idea of a software system architecture, in my viewpoint of this, we've got to go beyond just the individual device or even the home. We've got to consider the whole thing. This raises questions of who pays for this. A lot of the vendors are going to say, well, I'm just making the device. But when it goes out to the edge and to the cloud, somebody has to take responsibility for that. To be determined on a lot of that. Next chart. So, little example here. I mentioned I live in the mountains of Colorado. The first picture there on the top is actually part of my home electronics. Those are solar panels. They are smart solar panels. They have a device talking to inside the house, which talks to another device that goes out to the internet and reports to the manufacturer of how much, and the power company, how much energy we're generating, how much we're using, those kinds of things. Now, we've had that installed for about 14 years now. We're just upgrading it to new systems, but we had a lot of trouble integrating things. And the vendors had a tendency, when we contacted them, said, well, that's your network provider's problem. And the network provider goes, we don't know anything about solar panels. Fortunately for us, both my wife and I are pretty much techno geeks. We figured the stuff out. But your typical user of these systems, of these IoT AI systems, are not going to be like those of us on this phone call that can figure this stuff out. They're just going to want to plug it in and have it work. That's the kind of thing we got to work towards. The next one down below was my Snowcat, and it plows snow. It's like a bulldozer for snow. And it's got smarts in it. It's got a microchip and a comm device. And when I first got the thing, I was out running around, and all of a sudden the thing just stopped. Engine's running, but it won't move. Nothing will move. Any guesses to what I did? Well, that's one of the first things when you call a help desk is they said, have you rebooted your system? That's exactly what I had to do to the Snowcat to get it to work and to communicate. I had to turn everything off, wait a minute, and reboot. Now, should the typical user have to do that? Probably not, but this is the kind of thing we're all faced with when we want to make these systems good from a V&V standpoint. Next chart. So, and I'm not going to read every one of these on this, but we talk about verification and validation and techniques for verification and validation. And these are just the highest level techniques. You have the verification techniques over there on the left. Again, I'm not going to read every one of those. You have the validation techniques on the right of various kinds of things like simulation and prototyping and model analysis and quality testing. And then you have test activities and things that a lot of us are familiar with that kind of cover both bases. Things like error guessing and attacks. I'm a big fan of James Whitaker's attack concepts. That's what's in one of my books, actually. I'm also a big fan of model-based testing. We're going to get to that here in a moment. So when people go, well, there's only one or two things you can do in testing and V&V, wrong. You see there's a list here, and this list can probably be expanded too. Go ahead, next chart. So hopefully most of you are familiar with this. This is the classic V model where you have activities going on at a system level. The top there, hardware, cloud, internet things going on at a system level. You come down from there to the second red thing where with these IoT systems and AI systems, you have some kind of software interface that the human goes through. So we don't directly talk to the IoT device. That's a little small microprocessor. We don't directly talk to the AI system, we go through an interface. But that's part of the thing we have to think about testing in my view of the world here. And then down below that, you have the AI and the machine learning system, the models. Those we're still struggling with. They kind of show there as an infinite black box. The reason I show it that way is as these systems evolve and change and grow, I think we constantly kind of have to do V&V on them. Now, a lot of companies, a lot of projects are going to go, no, we're done. But I'm going to argue back on that and go, if the system is learning new things, if the AI system is learning new things, you have to check it at some various time points. Hence the infinity symbol there of testing in these worlds, I think will be an ongoing activity. As I already mentioned, though, who pays for that? The vendors? Maybe not. They don't have unlimited money. Do industry consortiums? Possibly. But I belong to a couple of consortiums, ISO and IEEE. We don't have that much money either. Then you go to the government. As these things get more pervasive everywhere, I think the government's going to have to step up in many cases and figure out how to test these things on an ongoing basis. To be determined whether that actually happens, by the way. Next chart. So these systems are large. Software testing, yes. System testing, I believe you've got to consider also. And AI model testing, absolutely. This is the one that a lot of us are currently scratching our heads with and struggling on. We know we have to do something, and you can't just ignore it. But a lot of the classic software test techniques don't exactly apply to an AI model. So what are we going to do? Well, we're going to run a lot more tests, first off. Running more tests implies a test architecture and some kind of automation in my book. So let's look at this concept of automation and test architecture next. So this is some charts that a friend of mine and I did earlier this year that I've reused. He's from Germany, Fraunhofer Focus, and myself. And we are working towards the concept of a software test V&V architecture of some kind. Now, I'll warn you again, this isn't one of those areas where there's a lot of people that disagree with us on this, but there's some standards out there. There's work being done on this. So it's the kind of thing that as you guys grow in your careers, you need to be aware of this stuff, that there's a software architecture over there on the right. There's a system software test architecture down there in the bottom right. That feeds into the testing activity, and these all feed into the development activity. So there's a cycle that goes on here in this architecture concept. It is something that's currently being evolved. Look at it a little bit more. Next chart. So how do these things play together? Well, software architecture is fairly well accepted in the industry. You see a definition there. And I don't read every single chart, by the way. I figure you guys are well educated. You can read some of these things for yourself. I kind of summarize things. But over there on the right, we have the software architecture, and that has to be mated with a test architecture. So there's different kinds of test architectures out there that are starting to come into play. Again, not everybody that I work with agrees on the term test architecture, but at least Mark Florian of Fraunhofer Focus and I believe there are such things. So this is what we've been working on. Next chart. And some examples of these things. You have the basic software system, as is, no real changes. That's what we plug into. That's what most of us are familiar with. You don't have to dream up a lot of fancy architecture to test that kind of thing. It's almost implicit in the system. Then you have the basic software system plus things like test support software and test support tools, automation. Now you're starting to add things into the test architecture that the customer will never see, but they will see the results of doing good testing on the product that gets issues resolved before the customers find them. Another type is a special test architecture software system. This is where we now introduce not only the software, but specialized hardware. For example, I worked for a long time in the aerospace aircraft world. We had very specialized test equipment to test our software because you couldn't fly the airplane until you at least had the software working well enough in the lab. So we had big computers and simulations. I've seen them at Boeing, I've seen them at Airbus, I've seen them at other companies. So this is kind of standard stuff. And then finally, there at the bottom, you have the software with even more unique hardware added in there, such things as computers, data recordings, electronic devices, and even mechanical systems. So how to think about that one is we have now AI driving cars, autonomous self-driving cars. The first sets of cars had the hardware with the AI driving the car around, first in just the parking lots of Google. Now they've moved out onto the streets in places in California. They still have a human there to override things, so they don't quite trust the whole thing yet. And there have been a few cases where there have been accidents caused because the specialized hardware software system hasn't worked exactly right. I'm okay with problems like that because in the long run, the system will learn. That's what the advantage of AI and learning systems is. But we've got to, time to get through right at the moment where it's going to be a little bit bumpy on these things. So there's a basic summary of some test architecture styles you can think about. This next chart. So in what we've been working on is something called the test profile, the test architecture, test configuration. This is actually done through OMG, Object Modeling Group. There is something called UML, Unified Modeling Language. We have been working on something called the UML Testing Profile, the UTP standard for model-based testing. So the idea here that we're just kind of summarizing in these charts is we're now modeling not only the software that we're building, as in like AI models and maybe models for like that self-driving car. We're now modeling the software system that's testing it, the test system, the UTP type of thing. And you can see the diagrams here. These are out of the UTP standard. Again, I'm not going to go through them in detail. It's a large standard. And if you're interested in these kinds of things, that's a good place to start with things. It is a standards group. The OMG is a big standards group. Next chart. So what does this buy you? If you go through and have a UTP model and UTP test configuration where you've modeled things, is it worth the extra effort? Well, here I'm showing not all the steps to get there. It's a lot of steps, but you can use these models to generate test code. We show a couple very simple examples here. The mapping to the TTCN3 language, and also a mapping to Java and Unit, JUnit. So the idea here is we would come along, build models, and instead of writing test code by hand, we would have the models generate the test code for us. We would then put that into the test environment and run these tests, not just hundreds, but maybe thousands or tens of thousands. Where this becomes an advantage, IoT certainly, but AI will need those kind of numbers to run tests, thousands and millions. And you get the test execution, but you also get the test oracle problem in part solved. So very high level view of these things. Next chart. So next steps on this kind of area. Start in your work about maybe becoming a test architect and working on architecture. I work with several people that are architects of these things. Take somebody thinking that big picture. You probably should be following standards, the OMG, IEEE, and ISO we'll look at here in a moment. If you don't do those things, if you just try and do testing the way it used to be with IoT and particularly AI, I think your risks are going to increase. I think that's going to be the kind of thing ultimately we'll have some good solutions for. They're in work right now. Next chart. So a little bit on standards. People have a love-hate relationship with standards. I'm the project editor for IEEE on the ISO, IEC, IEEE 29119 software test series of standards. It's been out for about 7 years now on 4 parts. It has to go through a revision process every 5 years. We just finished parts 1 through 4, I think about 1.5 years ago. Part 5, which is on keyword-driven testing, is going through ISO and IEEE right now. And anybody that's interested in supporting that, there is an ISO Indian representative I think you can probably contact. If you're interested in that, give me a note. I can probably put you in contact with them. He is the JTC1SC7 leader of everything, but I'm sure he knows other people. The standards have to get revised every 5 years. There's controversy. There's a lot of people that don't like standards. There's a lot of people that think they solve all problems. I'm kind of in the middle. I think standards give you a good baseline to start from. You can say, this is what somebody in industry said was a good starting point. Then you can add to it, tailor it, update it. Those things are all allowed in the 29119 series. You can do that. And there's a lot of people that say, no, you just need to do XYZ thing on testing. I don't believe it's that simple. If this were simple stuff, we would, not have the jobs we have, and they would be replaced by computers. So next chart. So I mentioned the parts. Here's a little summary of them. Part 1 is general concepts, just really an introduction. Part 2 is test processes, things like planning, design, those kinds of things. Part 3 is test documentation. Basically, almost all the standard kinds of test documentation in outline form that we could think of. Most people would only have 3 or 4 of those. I don't know if anybody have. I think there's something like 20 of them. I don't know anybody do that. But they're there for those people that need that. In part 5, I mentioned already, keyword-driven testing is currently in work. I will mention there are a bunch of other parts that are all being worked. There's an AI one that I'm supporting. There's a model-based testing one. There's a performance testing standard. There's one on large complex systems, like we're kind of talking about here, and financial systems. So these areas that are currently in work are very specialized, but we're always looking for people, one, to support them, but also help people in bringing them into common use and helping international trade and things like that between, say, people in India and people in the US. We have a common framework and the standard for that. Next chart. So, a shameless plug here. There's also, besides the standards, there's books and training. The people in Test Tribe were mentioning you've got some good training going. That's great. My shameless plug is my 2 books. One of them's still out and very available. The one that's been out for a few years, I think, is getting harder to find. And I think they're in ebook format too. But those are out there and available, along with the other books on both AI and software testing and development. I'm constantly reading. I think we all have to be doing that. It's a constant, ongoing battle. Like I said, I've been in the industry for over 40 years. The things I learned 40 years ago don't apply now anymore. Next chart. Skills. Okay. This is my recommendation for you all on where to take your careers, things to learn. I'm a big believer in skills and building skills. Hardware and testing of the hardware can be very important for some of these systems. Systems engineering, also very important, and software engineering and testing. All these things are areas that I've either actively done or at least supported on the peripherals. For AI and things like that, I think you have to identify the project, the planning, the risks in particular, the documentation for them, the programming and models of them, and understanding the models in the AI, and then the process relationships to like the standards that I was just mentioning. And my question to everybody is, how many books are in your library? I've got a library of somewhere on the order of about 100 odd books and probably another 100 or 200 standards. I'm constantly referring to those. Next chart. So AI V&V tester skills. This is still a new area. We're still learning this stuff. I think the standards from ISO are going to help, but they're probably a year or more from being ready. And we're having a lot of discussions on them. The V&V stuff, there is an IEEE standard 1012 on V&V, but a lot of people in the ISO world don't like it because it's very specific to things in the US. We'll see where that goes. But at least there's a V&V standard out there. One of the other groups I support that's big, mentioned in the government publications, is bias issues. And there's one for both ISO, and then IEEE is 7003. Those things are in work. I think 7003 might be out in the next year or so. I support that group. It's constant learning. And by the way, my V&V team that I used to run, IV&V team, lasted for 20 years. So these things can go on for a while. Go ahead, next chart. So security, real brief head nod to that. I've been concerned with security. The book that I wrote has a whole chapter or 2 on it. I don't have the time to go through each one of these areas on the infinity chart, but these are the kinds of assessment and test activities you should be doing, things like pen testing and social engineering, taint analysis and spoofing. Those are all in the book. And it's a constant battle with the black hat hackers that are out there. And I like to encourage testers to become white hat hackers. And it's very important that we have secure systems. Next chart. So some other skills in the IoT: software engineering, know about it. System engineering, know about it. And have partners and suppliers in the product security risk area. One of the things we can do with IoT and AI is monitor what the bad guys are doing. We're starting to see that in a lot of companies. This gets into issues of privacy and things like that. Understand that, but it's got to happen somehow or another. And then quality characteristics, such as listed below: performance, interoperability and integration, reliability, again, security, attacks, and maintainability, and the list could go on. There's an IEEE standard 982.1 that's just a few months away from being published that I've been supporting. That's going to have a lot of good stuff in it for this area. Go ahead, next chart. So, skills in this area. Kind of mentioned the chart earlier, the house and the edge and the cloud. We're going to see development, but at some point it goes away. But I think the testing in the V&V and the data analytics and the AI there in the center, that's going to go on forever in many of these systems. Not everyone maybe, but many of these things. We may do some development updates and things like that, but I think ongoing testing V&V using the data analytics and the AI is going to be the kind of thing that goes on. That's going to change some of your jobs from being manual testers to things like data analytics and understanding what the AI is telling us. And the companies are going to be very interested in that stuff. So good job opportunity there. Next. So real word chart here. AI and analytics skills for testers. Once upon a time, I was a mathematician. So this isn't that scary to me. I know a lot of people that didn't have a math background. When you start talking, massive data and data analytics and statistics and things like that, they get nervous. But with the help of the AI systems and things like data flow and static analysis tools, I think we'll be able to mine the data and look for the things that we need to work on and improve. For example, in the security area, if we see certain attacks happening more and more on our IoT AI system, that probably indicates something we should go do more work on. Other skills I've kind of mentioned: system engineering, creating these test architectures, knowledge frameworks, statistics. Again, I know people are afraid of statistics, but they're not that bad. Or at least hire somebody that's a good statistician in understanding these things. Next chart. So what's happening with this stuff? Well, the 29119 series was questionable about 5, 6, 8 years ago, but it's living on, it's growing. It's got its areas for improvement, but as both the good and bad, we got to keep working on this stuff. That's a big part of my job. There's different views. Do you have the AI view school? Do you have the context-driven school? Do you have the standards? I bounce them back and forth between those, and everybody in the schools seem to think that I should just go one way. I try and learn everything across the board. IEEE ISO 2919 is evolving and expanding. As I mentioned, there's a big working effort for AI. I'm guessing we're more than a year, maybe 2 years away from having that thing released. But it is in work, and I know there's people both in ISO, but even more so in IEEE that want to see that thing happen. So that's future work that's going on in that stuff. Next chart. So summary, gave you some insight of where I see things going in the future on this stuff. Some of these things are already up and working. I will say, particularly on the AI and IoT AI side, it's changing really quick. So if something I just said now turns out to be not quite right in 6 months or a year, I'm not going to be surprised. You shouldn't be surprised either. The paper and things that I did on this said, this is an ongoing work. That's just the way life is in this business. The focus in my mind has to be on the V&V and IVNV, has to be on security, has to be on that AI and data analytics stuff. Those are the areas, if you're wanting to learn and build skills, there's the ones I'm pointing at. Not that they're the only ones, they're just the ones I like. Next chart, I think that's the end. Yep. So there I am when I was in Greece last year, which is now burning this year. So I was there before the fires. The books, my toys. I do a little bit of training. I do writing and consulting, but not much consulting. I'm mostly what we call in the U.S. semi-retired. But I'm always happy to take questions, get emails. But most of all, I'm a ski bum and plow operator. And I realize most of you have no idea what snow skiing is, but that's what we do here in Colorado. And I love to travel. I've been to India 4 times, always have a good time there. So it's a nice country, a lot of people. And that's my presentation.
Okay, thank you so much, John. That was a great presentation, the points that you kept and everything. We have quite few questions now, so we'll take those. Okay, so we have a question from Nilesh, and that is where to learn security testing and testing for AI, ML, IoT. So the things that you talked about.
Okay, sure. The security testing, I will point at the IoT book. It's got a whole chapter on security testing. There are a variety of websites that book also points to, and I think if you do a search on security testing information websites, you'll probably come up with things. I tend not to want to recommend particular websites or particular tools, because then there's always somebody that goes, yeah, but my tool's better. So I kind of try and talk in top level generalities and encourage people to go off and do some research. And as I said, I think the book is available online through Amazon or Google or one of those. I know I haven't checked in a while. And there's also some ISO standards that I don't have off the top of my head, but if somebody sends me an email, I can probably point people at that. So that's how I'd answer that question.
God, thank you so much. But great presentation, John. The way you described everything with examples and all, it was amazing. Thank you so much for doing this with us.
Been doing this stuff for a lot of years, and I get accused of giving way too much information, but I figure you can always go back through and look things up. I'd rather have too much information than not enough.
Yeah, it's with us, and thank you to all the attendees for joining us.
It's late. It's late there for you guys. You all need to go to bed.
Yes, exactly. And that is why I'm thanking all of them for just staying with us till the end, and that just shows the passion they have for learning and understanding new things. So thank you
Okay.
to all the attendees, and thank you, John, once again. Would
All
definitely love
right.
to meet you again.